I don't know. Yes? Oh, damn. Okay. Okay, so I was watching some scientific breakthrough TV the other day about they have JWST, that new satellite that they have in space that just it to date is the most powerful satellite that humanity has created. Long story short, it can see via infrared the rims of the observable universe and just about everything in between. So it has been uncovering a lot of new information. It has been helping solidify and eradicate some ideas in physics, quantum physics, and astrophysics alike. So one of the things that has come up via some of the discoveries that it's had is, okay, so first let's talk about the double slit experiment. This is why
The experiment of Thomas Young, the double slit experiment. It was a real coup in physics and led many scientists into the study of quantum mechanics. If you throw solid balls at a shield with a slit cut into it, a single diffuse strip designating the strike points will appear on the screen behind the shield. If there are two slits in the shield, then there will be two strips. But how will waves behave if aimed at the shield? They will pass through the slot and spread out. The greatest impact of the waves will be in the line of the slit, as in the case with the balls. But if you add a second slit, everything changes. A number of alternating interference strips will appear on the projection screen. And when we shine light on the two strips, this is exactly what happens. And this is how Mr. Young proved the wave theory of light. If light were corpuscular, like a particle, instead of wave-like, it would behave like the balls, and the screen would show two strips of light corresponding to the two slits. That didn't happen. Later, it turned out that electrons and protons behave exactly the same way, showing that they also seem to exist as waves and not as points. There was one assumption that perhaps light and the others were particles, and that somehow the particles bumped into each other and flew apart. So, to test this, physicists decided to shoot electrons at the target one by one, single file. And what do you think happened? The strangest thing imaginable. The interference pattern still appeared on the screen. It seemed that the single electrons somehow divided into two waves, passed through both slits, then interfered with themselves. Impossible. So physicists tried to find out through which gap the electron actually passes. They installed measuring instruments to check this. Another seeming impossibility occurred. The electrons stopped behaving like waves and began acting like particles, and left a trace on the screen of two distinct strips with no interference. They had to admit something completely mind-blowing. That the fact of our observation or measurement destroyed the wave function of the photons, causing them to become like points, corpuscular. The electron, under the influence of observation, behaved like a particle, flying through one slit and not through two. Interpretations. Well, it certainly looks like the work of a game engine, doesn't it? This might make you think that our world is running like a game on a computer. The computer's power is not enough to each and every particle, so it uses a simplified model and applies precise calculations only if an observer needs to look at the particle, so as not to break the illusion of the reality.
This is why I put it in the group as a preemptive measure. So in the double slit experiment, long story short, they end up realizing that observation changes the way that photons, or rather, I think they used electrons. Yeah, they used electrons. That viewership changes how particles react. A lot of things, including light, have both particle and, well, light is the only one that has, allegedly, both particle and wave-like behaviors. But the reason that they realized that is only because of the double slit experiment. In the experiment, when they shoot the damn photon through the slit, it splits itself and somehow goes through both slits at the same time. And on the other side, instead of the particles coming out and making an impression of just where those two slits are, it makes like a wave formation, a wave pattern, which technically shouldn't be true as far as the classical model of particles and molecules is concerned. But that is how they realize that light has wave-like and particle-like behavior. So the thing is, observation is what makes light behave like a particle as opposed to a wave. So when something is observed, seen by the eye or even a camera, even a computer, it will behave in a particle manner and not a wave. So it will, in essence, when you as above, so below this, it will behave like a solid piece of matter as opposed to an ethereal entity, an ethereal object, okay? Observation changes that. So what is observation? Observation is the collecting and recording of information. Information, scientifically speaking, means not just the classical idea of what we mean information, words and ideas. No, it also means every time you look at something, your eyes are recording and observing that item. You're seeing the color, the texture, the depth, all of that is information, and our brain takes it and turns it into what we perceive as an image. These things are there but not there. But that is the thing right there. In our reality, we know that it is concrete. We know that if you punch that wall is absolutely there. Your arm is at no point going to just go through it like it didn't exist. We know that our reality is concrete. And it doesn't matter if, I love and miss you too, Jay. It doesn't matter if someone is paying attention or not. You know the old saying, does a tree make noise in the middle of the forest when it falls and nobody's there to witness it? That was, that's some old timey shit, but what we quote unquote know now is that yes, it does, right? Things are still going to be affected by the falling of that tree, whether or not somebody is there to technically observe it. But the idea here is, what if we are not the ones that are observing? So now we start to fall into the creation of monotheism. What if the person or entity that is viewing is always viewing, and therefore in our reality particles always behave like particles? We have solid matter because we are observed, right? And we might not be the observer as we think we are, just because we have eyes and we can see all the shit in order to navigate it. Maybe the reason that matter is solid here is because there is a more omnipotent consciousness, if you will, and I'm using consciousness very loosely, that is viewing. So where does that take us? Now you can kind of understand how people fall into religion and monotheism and feeling like there has to be somebody on the cloud somewhere watching their ass, some type of sky daddy. You can kind of see how that begins to shape and make a little bit more sense, and hopefully that gives us some empathy towards those silly people. But if there is an intelligence that is viewing from, let's say, a higher dimension, we know that we are the third dimension, which means that there are two beneath us. And that's really not, that difficult to understand. Two dimensions. Every movie you've ever watched, show, even me on the screen right now, is a 2D projection of something that is technically 3D. Okay, so you're seeing me right now. If you turn your phone to the side, you will not see the side of my profile. You will not see my head. You see my face. It is flat, 2 dimensions. It is tall and it is wide. Okay, there is no actual depth here. This is an image. Exactly. This is an image. Exactly. But in one-dimensional things is stuff that has no height. It has no what is it called? what is it called? It's not called height. Whatever. It doesn't go vertically, only horizontally. So stuff like germs, amoeba, shit like that. You would want to say insects, but that's not true, because on a tiny scale, an ant is still a 3D entity, you know? But single cell organisms is what I'm getting. Boy, single cell organisms is what I'm getting at. Things that don't have a concept of height or depth. Okay, that is what they're missing from our reality. Things that basically are living inside of our bodies and have no idea that they're inside of something larger than them. Now that concept applies to us as well, is the point of the synopsis. We could be living inside of some higher, bigger, more intelligent being, entity. I don't know, because I don't necessarily want to humanize it and make it like it's personified in some way. It's difficult to step around that. But so the idea that, now let's jump ahead. And I told y'all this was going to take a while. That's why I didn't want to do it. So this new theory is talking about black holes, right? Because what do we say observation was? It is the absorption of information and the recording of said information, right? Black holes at the event horizon, which is, oh, I wish I could, can I do that? Is that one of these filters where I could put like a image as my background? I'm not going to try to do that right now. But, okay, imagine a black hole. The part at the center where obviously the gravity is at 0 point, where it's at infinity, and nothing can escape, that includes light, and that includes information, okay? Everything that has been pulled into a black hole has been absorbed. That's the first half of observation, okay? The recording part, so at the event horizon, which is the outermost brim of the blackest part, it is not the part of the black hole where you start to see light distort. It is that very thin strip where it's like you see the light beginning to almost disappear. It's that first little, that tiny little strip right there in between those two worlds, if you will. That part is called the event horizon. And the event horizon, it records all of the information that has ever been pulled inside of it.
Meanwhile, quantum particles behave as waves, a set of probabilities, right until the arrival of an observer. And solely after that, the particle becomes something particular that can be measured. But in our world, reality exists no matter if anyone observes it or not. Or am I wrong? Actually, the quantum world isn't just an imaginary model that physicists use to run their experiments. It's our reality. The entire universe consists of tiny quantum particles. It looks like it used to exist as a set of waves in a superposition before there appeared an observer and our reality took its present form. But who is this observer? A group of scientists from the University of Chicago and Princeton University tried to find the clue. The team included Robert Walk, Gautam Satishchandran, and Dane Danielson, who started wondering what could happen if a supposed observer is placed beyond a black hole event horizon. The thing is, anything that enters this area can never come back, including information. Consequently, information can travel from a quantum particle to an observer inside a black hole. But it can't be the other way around. In 2016, a scientific team led by Stephen Hawking found out what actually happens there. When a particle falls into a black hole, information about it doesn't vanish beyond the event horizon. It stays around the black hole as very weak radiation. The researchers called this information-rich halo soft hair. In 2023, researchers Wald, Satishchandran, and Danielson, mentioned at the beginning of the video, assumed that this hair functions as an observer in relation to particles beyond the event horizon. They think a particle leaves a trace of information not only when it crosses the event horizon. Soft hair records its further movements into the depths of the black hole too. That's why under the influence of this radiation, all superpositions outside the event horizon will switch from the ambiguity of the quantum world to our reality. It seems that the black hole is that very almighty God that forces the quantum particles in the universe to take a certain physical shape.
Observing and recording, right? And what I mean by it's recording it is if two of us went into space and one of us stayed away from the black hole and one of us went inside, the person who was on the outside looking in would see the individual go, get to the event horizon, and then it would seem to you like they stopped moving. You never saw them get pulled in. You never will see them get pulled in. It's not gonna be like in the movies where you see the event happen. They are going to freeze in time. The image, rather. The information. Oh. Listen, you loading me up tonight. I really miss you. But the event horizon basically records all of the information that goes inside of it. It never disappears from the event horizon, even though the matter itself will be gone, has been absorbed, and we still don't know what the fuck happens inside of black holes. There's no technology that will know. I think that is going to be the more difficult part about solidifying the idea of this. But what we have on our side is we have non-tangible science, metaphysics, you see, that can actually help us crack this. Because I suspect, and I haven't done it, but I suspect that since the soul vibrates in infinity as well, the same way that a black hole does, one could probably essentially like almost astral project, right? But that's so risky, right? Because we don't really know, you know? So again, it's just a theory, just an idea, but I do think that the ultimate observer could be a black hole. Now, we have a black hole at the center of every galaxy that we know of in existence. The black hole is what is pulling everything together in order for stars and planets and all that shit to even come into fruition. The beginning force of gravity that begun to pull all of that material together in the first place is a black hole. Every galaxy that we know of has a black hole at the center of it, including ours, and it's called Sagittarius. Sagittarius A is the name of our black hole. So who is to say that at the center of the universe itself, there's not a very big black hole? One that has recorded all of existence. And that goes into, I told a friend this when I was venting about this today. I told you my mind has been going crazy all day because this is a huge concept to even consider. Imagine if the Big Bang and its counterpart, the Big Crunch, I'm sure you can deduce what that fucking means. What if they happened instantaneously, sort of like a hand opening and closing? Now, instantaneously to those of us that are inside of the creation would feel like billions, maybe even trillions of years, because our concept of time, or whatever the fuck that is, would be severely stunted by the fact that we are the created and not the creator. Ugh, this is starting to get preachy and weird. I have to figure out a better way to say that because I don't like that. But to us, it would seem like a very long motherfucking time. To whoever is conducting the experiment, let's put it that way, it would be instantaneous. The same thing like you having an ant farm. Them ants don't know what the fuck is going on, and they're all going to die before you, well before you. You know what I'm saying? Like, they are basically insignificant compared to your complexity. Now, we're spiritualists, we know better than that, but you know what the fuck I mean, you know. They are basically, they are ants. There's a reason why we use that term in almost a derogatory manner. You're an ant. You know, something that is tiny, and sure, it might be plentiful, and the fact that it's plentiful is probably the only reason that it survives, because it doesn't really have longevity or high-level extreme intelligence enough to consider ideas like this one, as far as we know anyway. So it could be that at the very center of our universe there's a very giant black hole. Black holes already resemble eyes, that is observing and recording all of existence. Existence that could have all happened at the same time. Excuse me. In spirituality we say that there is no such thing as time. Time is all happening at the same moment. All of it is now. And because of our third density, because of our 3D perception, we experience it as a linear phenomena, but we can't really say that it is. We don't have the clearance to say that it is. And let's say, for the sake of this conversation, that it is not. If everything that ever could happen did happen at the same time, good, bad, ugly, if all of existence existed at the same time and in one space, we would never know. Not where we are right now. Not how we are. That's an interesting concept. Yeah. Time, that's a whole nother live. I think I should, because I would have to. I'm reading a book on time, and it's one of the most difficult books I've ever read, honestly, because time is very, the idea of it is antiquated. It's kind of an old idea, but we can't, it's difficult for us to escape it, because we have to communicate. We have to cooperate. And for that, we need boxes. We need lines. We need 90-degree square angles to make things make sense, so that the pure amount of us that live on this blue marble can cooperate and communicate. We have to have standardized methods. If you really think about it, numbers don't exist. Let's take it a step further than just time. Numbers don't exist. They're concepts, and they're concepts that help us organize and categorize existence, but they don't. The number one doesn't actually exist. It's an idea. The idea of something singular, something that is standing alone. Yes, okay. But one doesn't really exist. So time doesn't either. Y'all are probably hearing every word that I'm saying 7 seconds later than I'm actually saying it. By the time you hear it, I'm not saying that anymore. By the time I press end on this, or finish is what the button actually says. By the time I press finish on here, I'll be and put my phone down, locked it, and put it on a charger by the time the video even ends for you. So time is extremely relative, and with it being that relative, it could be said that it doesn't exist. Weekends go fast, but the work week takes a long time. Time dilation, how much attention you're putting on something, it changes the effect that time has on you. So time is extremely fluid. It's very difficult to tie that down, and I wish I had the time to, no pun intended, but my man coming to get me in an hour and a half, child. Yeah, I remember they said something about they were going to stop doing daylight savings. And from what I understand, they could theoretically, stop honoring daylight savings. They could theoretically, but it throws the calendar off. It takes like 72 years for us to be able to see how it's fucked up, but it throws the calendar off if they don't equalize that. That's what daylight savings was supposed to be for. Now, that is also white man's education, so I don't know. I don't have the instruments to actually measure the sun and the moon. It be down to the millisecond. But, you know, according to how we grew up and when we thought the shit that was in the books that we was reading, daylight savings is absolutely necessary. But that I did see that they said they were going to stop doing it somehow, some way. I don't know what the fuck, you know, they're going to do to fill that gap. Because, baby, I need that hour. I need that hour in October to go back so I can be asleep. But yeah, I love y'all. Just to reiterate, I'm going to be putting the instructions for next month's ritual in the group in 3 days. On the full moon, we're going to perform it together on the new moon. I'm going to create an event in here so everybody will get a notification. You will know.